Well, good afternoon, everybody. This is Spencer Warman again from Harris Geospatial Solutions. Today, we're here to learn about the IDL, to Python bridge. We have with us James Lewis as always, but today we have a special guest joining us, Greg Terry. Greg has been with HGSI for over 15 years and currently serves as the director of our sales engineering team. In his capacity as Director of Sales Engineering, Greg helps determine the future of IDL. If you've been a longtime user of ENVI or joined us for any of our conferences or events, there's a better than 0% chance that you've met Greg somewhere down the road. He's kind of, for lack of a better phrase, he's kind of the face of ENVI for our D&I customers. As many of you know, as many of you on today's webinar know, ENVI is built on IDL, the interactive data language. If you've participated in any of the previous webinars, you've already heard a little bit about IDL. IDL is an interactive analysis and visualization platform that integrates a powerful array-oriented language with numerous mathematical analysis and graphical display techniques. IDL is what makes ENVI so powerful. Similarly, Python can be used for data visualization and analysis. Python is an easy-to-use language that makes it easier to get programs working. Today, you'll learn about the IDL-to-Python bridge. This class contains a set of static methods that allow you to initialize and interact with Python interpreter, as well as providing a mechanism for calling IDL code from Python and Python from IDL. By the end of our webinar today, you'll learn how you can blend IDL with Python in the same environment, enabling you to bring the best of breed image analytics and one of the most popular open source languages together to create robust image processing scripts. With that, I'll hand it over to Greg.
Well, hello, everybody. I appreciate everyone dialing in and participating once again. A little bit more about myself. In addition to the 15 years with the company, I was also a customer. I used IDL in my previous jobs, and also I saw ENVI grow up from its birth to what it is today. So I've been around our products for most of my career. It's really exciting. And so today I'm pleased to talk to you about our IDL to Python integration work that we've been doing over the past few years, give you some demos, and also show it to you live. So there we go. All right, so that's enough about myself. So here's a list of some of the topics we'll be talking about. We'll get into some of those in more details than others, but you'll see these. This course is, if you've been attending some of the seminars that James has been presenting, he's been talking about the ENVI application and all its wonderful tools and capabilities. Today, this is going to be different. We're going to go and focus on what I support our customers doing is extending ENVI with IDL and integrating it with other tools like ArcGIS. So we're gonna be at the API level. We're gonna be doing programming at the command line and showing codes. This is gonna be totally different from the other courses, but I do want to say though that those of you, there will be an ENVI, kind of ENVI centric, but for those of you that are our IDL customers that don't use ENVI, don't despair. This is for you too, because as Spencer mentioned earlier, ENVI is written in IDL. So, and we'll talk about this in detail later, but it has a lot of functions and capabilities that we will be able to leverage with Python as we go along. We'll show you those. We'll show some examples and run those, get a chance to run those yourself. So this seminar is going to be about an hour, 15 minutes to an hour and a half. Sorry, I tried to squeeze as much as I could in there. It's going to be recorded, so if you have to drop off, don't worry. We provided some materials too that hopefully you've had a chance to download, especially those of you that want to try this as I'm going along. But if you didn't, don't worry. Just you can sit back, relax, and listen and watch, and get the recorded seminar, and then get the materials, and then you can go along at your own pace later on. So this course is also really geared towards those that have some experience with scripting and IDL and or Python, and also those that have been developing custom ENVI applications, which they would have used IDL too. So it's really geared towards them. But today's materials are not too deep. We're not going to get into the gory details of the languages. We'll highlight those things that we need to highlight, and then we'll run some of them right there live, and you'll be able to see how they work, and then later on you can try them out for yourself. Okay, so the requirements for this is you need ENVI and IDL, of course. We're going to be using the latest version, 5.5.3 of ENVI and 8.7.3 of IDL. You'll need this Mdpi Engine. We'll talk about that in detail. We're going to be using Anaconda. Anaconda 3 is it's recommended mainly because it packages Python with it, and it packages a lot of the Python libraries that we're going to need, or you would want to need. You don't have to use Anaconda though. You can get your standard Python install and get it to work as well. We're going to be using Python 3.6.10 for this. There's also going to be a section in here where we're going to be working with ArcGIS. So if you have ArcGIS already, that's great. If not, don't worry, you can follow along with this as we go. You will need, though, our Mdpi for ArcGIS, which James probably mentioned earlier in his presentations. We're going to be working with Arc 10.5 or 10.6 and Arc Pro 2.2 or higher. And then also suggest, if you're doing this and following along, you need a software editor. We'll certainly use the IDL development environment, but other ones that I'll be using today include the Visual Studio Code. You can also use Notepad++ or PyCharm, and I'm sure there are others out there that are suitable. Okay, so some of the objectives we're going to do, we're going to demonstrate some of the capabilities of our IDL-Python integration. We'll talk about this bidirectional IDL-Python bridge, where we're integrating Python routines in IDL or ENVI routine, or integrating IDL with ENVI routines in a Python routine. And forgive me, sometimes I may say IDL, but and it may mean that directly, but also it might be synonymous with ENVI as well. So consider ENVI is more than just a desktop application. James showed you that quite in detail in the last few seminars, but it's also, it's like I mentioned, it's an IDL application with an extensive library of routines to do all kinds of things. And we'll come back to that later, but it also has that API, publish API via IDL that helps us leverage the IDL and Python work we're doing. And then we're going to demonstrate some stuff with ArcGIS as well. James focused on, he showed you how to take ENVI routines and publish them into Arc Toolbox and use them there. We're going to show, one of the demos I'm going to show is how to bring ArcGIS capabilities into an ENVI routine. And so, and that works because Python is ArcGIS's scripting language as well. So, okay. All right, so we're going to break this down a little bit more detail. So when we talk about the IDL Python bridge, we're going to the nomenclature we're going to use, if it's IDL Python, meaning we're in IDL and we're calling Python. The Python IDL bridge is the opposite. We're in Python, we're calling IDL, and IDL in this case could also mean ENVI. So, and then we also have this, for those of you that use Jupyter Notebooks, we're not going to demo that, but at the end I have a graphic of that. You can use Jupyter Notebooks with IDL too. There's this Mdpi engine I mentioned earlier. This is Python enabling us to call our ENVI task. We'll talk about that in a little more detail later on. And then for us that are using the ArcGIS platform, you have this Mdpi for ArcGIS. This enables us to call ENVI functions in ArcMap and ArcPro. And then, we've been doing a lot of work enabling ENVI and IDL to work in the enterprise and server environments. So we developed this Geospatial Services Framework. So GSFPy for ArcGIS enables us to run ENVI tasks in the ArcGIS Enterprise framework. So it also, GSF also supports Python as well, so you can run it. If you want to leverage Python within GSF, you can certainly do that. And one thing I wanted to point out is that we've had a long history of integrating other software languages with IDL. We've long time been able to support calling or wrapping Fortran or C or C++ executables and making them available and as part of our IDL and ENVI workflows. We also have an IDL Java bridge as well, so you can work with IDL and Java. There's a COM connections as well. And then for the enterprise environments through GSF, we can enable access to those routines through RESTful interfaces. So integrating Python with IDL is not a new concept for our products. Okay, so here's a quick overview of the bridge. We've had it out there since ENVI 5.3. This is about 6 or 7 or 8 versions ago, a few years now. It's just like IDL and ENVI. We're available on Windows. This is available on Windows and Linux and okay, go away. Windows, Linux, and Mac. And then we support Python versions 2.7, 3.5, and 3.6. If you notice at the bottom, we will be soon to support 3.7 and 3.8. We recommend using Anaconda, as I mentioned earlier, but it's not required. You definitely need the NumPy Python library. And I mentioned what the IDL-Python and Python to IDL bridges are all about. The best part of this whole thing is that if you invest in IDL and ENVI or IDL especially, you get this Python integration at no extra cost. There's no added modules you have to buy. If you have using ENVI, well, you got to pay for ENVI, obviously, but the integration with Arc doesn't cost you anything from our point of view. You also have to have the ArcGIS platform, but all this is all built in and ready for you to use. Got that. Okay, so some of the capabilities, just some, I'm not going to read all of these, but I'll highlight a few of them. So this Python bridge gives you access to all of IDL and ENVI routines, as well as the Python modules and libraries. So you can mix and match those things as needed. When you look at some of the code, it looks very seamless. Okay, go away. Why is that coming up? So it's very seamless between the two languages. You'll see some commands look almost indistinguishable between the others. Some of the things are handled behind the scenes, so we don't have to worry about it. This case sensitivity and row column major. It's all handled automatically behind the scenes for us, so we don't, as programmers, not think about it. The data conversion between IDL arrays and NumPy arrays is all handled behind the scenes. You'll see some of that in action. There's more details than I could possibly cover here. So consult our help, either that comes with our installation or on our Harris Geospatial website. The help is also there, so you can check it out there as well. Okay, so the next part I want to cover, I probably want to, I wanted to cover this because it's important to make sure, give you some guidance on setting your environment up so it all works. So, so we're not obviously going to go through the install process. We've provided a lot of these materials in the download for the seminar. If you haven't done that already, don't despair. Like I said earlier, you can do that later. We're not going to walk through the install. Some of it's fairly straightforward, like installing ENVI and IDL. Just load the DVD in or click on the install script and it installs fairly easily. Python and Anaconda are fairly similar to do that. It's fairly easily. We provided Anaconda 3, 5.2, this installer here that's here. This will install 365, and then to get 3610, you just at command prompt just enter that command. You also need this scikit image Python library and also the pillow library. We use that for some of the exercises in the training manual, training stuff. You'll need Mdpi Engine. Again, this is free. Just do a pip install. I'll skip this environment variables in a second. If you have ArcGIS, either ArcGIS Pro or ArcMap, install that, and then you'll need one of these installers that are either on the DVD that you get or available in the downloads as well. Now, going back to the setup. Now, those are the easy parts. The tricky part is getting your environment variables set up. So, because you can have multiple versions of IDL and ENVI, you can have multiple versions of Python. And if you have ArcGIS installed, it has its own version of Python. So making sure you're talking to your IDL and Python are talking to each other, and you have the right versions talking to each other. We recommend using batch scripts to kind of set up your environment. Even the Anaconda and Python help discourage kind of setting these global environment variables. Just because what I said, you could have multiple things, and you want to make sure the right versions are talking to each other. So we provide in our course materials this IDL.py-py.batch file and a load ArcGIS Python batch file. We're focusing on Windows for this seminar, but very similar things you would have to do if you're working in Linux and on the Mac. So here's a example of the IDL-py.batch file. This is a template. You'll need to customize this for your installation. So you want to set this Anaconda _install variable to wherever you installed Anaconda. I'll show you later on what mine looks like. You'll need to set up the IDL install variable to point to where you installed MD and IDL, or at least IDL for sure. And then it's all about setting the path variable. So you need to append these directories, specific directories within your Anaconda install and your IDL install, and append them to the path variable. And there's one more thing variable you need to set is this Python path, and you need to add some of the IDL directories there as well. And then the last command is this call activate base. Since we're using Anaconda, you can have multiple bases there, so or installations. So you'll activate that. When we're using ArcGIS, we'll have a very similar one. We'll talk about that when we get to that. And then you use this by starting the command prompt, running this thing, and then this batch file, and then you're already set up to use either Python or IDL together. Okay, so all right, so this is how you would see it run. I just highlighted these. I've started my command prompt, went to the directory where this batch file is, and I typed it in, and then I typed in Python here. See the Python interpreter show up. It's got 3610, so I got that working. And then exit that, start IDL. I got IDL started up. So we'll see this in action shortly as we go along. All right. So what I'd like to do now, now that we got the formalities out of the way, let's get down and start showing some real examples. So first thing we're going to do the IDL Python bridge. So this is IDL calling Python, or calling Python from IDL, however you want to say it, the Yoda way, I guess. But so focus on the lines that are highlighted here. So I'm in the IDL command line or in the IDL script, as you'll see later. To import a Python library, there's a python.import command, and then you give it in quotes the name of your Python library, just like that. So this gets assigned to this ran variable here, so it becomes an instance of it. And now we can run the ran function that creates a 100-element array of random numbers. Now, this creates a NumPy array, and we're assigning it to this IDL array variable, ARR. So as I mentioned before, behind the scenes, we don't have to think about all that transfer and how that happens. It all gets happened by the bridge technology. And so now that I have this IDL array variable, random number arrays, I want to plot it. So I'm going to use the pyplot library from matplotlib, and get an instance of that, and then I'm going to pass to that plot function that IDL array. So I'm passing an IDL array back into a Python function. And then I'm going to execute the show command, and I get this figure on the right. So we're going to do this in a second. One thing I would like to point out that my engineering folks pointed out to me was, this is just a simple example, just kind of get us warmed up. Generally, we don't want to bring in widgets or plots or graphic type objects from the other language into this. So rather than bring a MATLAB plot in, I typically would rather use an IDL plot, mainly because if you do this too much within a certain session, the session might become unstable, and it's because just the way IDL and Python operate with some of these. So, but for this example, it's nice and short and simple, and it works. So let's go see this in action live. So I'm going to switch out of here. I meant to. I'll show you while I'm here. I'll show you the distribution of things that you have, at least how I arranged my code. So there was you should have gotten a zip file that had all these directories in here. This Python integration directory has the course materials that I have in an HTML format. So that's this thing right here. This is the talk track that I'm following, more or less. But use this along with the recorded session to kind of walk you through all of the steps that we're going to go through. It's all documented in there with all the graphics and code and descriptions set up in different chapters. So feel free to look through those and follow those a little bit easier. I'm going to follow the PowerPoint, which you got a copy of as well in this training directory. I installed this in SQL and training, so a little bit easier. There should be a PowerPoint or PDF file that this IDL ND Python. You probably got a PDF, but it's located there. And then I separated all of the code into these different directories. So since we're in the IDL Python bridge work right now, we're going to go into that directory and the code directory. And at your Windows Explorer command prompt, right there in the bar, just type CMD for the command prompt. And then in this directory, there is first typo of the day. Okay, won't be the first, last. So, and then there's this IDL-py.batch file in there. I'll show you what it looks like in a second. Let's just type that. Okay. So it set my invariant variables, and now I got my Python Anaconda all together. So I'm going to swap over. Leave that there for a second. I'm going to go to Visual Studio Code, go to that same directory. And in here, here's that IDL-py.batch file. Here's how I customized it for me. So I installed Anaconda in this folder. Here's where IDL and ENVI are normally installed. If you have just IDL, then you would have Harris IDL 7 instead of the ENVI 5.5. And then here's how I set that same updated the path variable and this Python path command as well. This Qt plugin, sometimes I have troubles displaying that graphic, so you need this in there potentially. And then I call this activate base. So you have this in your distribution, which we ran. We're going to run, instead of typing those commands, because I don't trust myself typing those, so when I'm presenting, we have a little profile here that we're going to run shortly in a second that's going to type all these commands for us. So that's what it looks like. So the same command you just saw. So to get out of here, we can go back to our command prompt, and at the command prompt, type IDL. So we bring up the IDL interpreter, and then at the IDL prompt, we're just going to type .run and IDL, and then just hit tab. It should find it, and we're going to hit enter, and we're going to run that routine, and we get our plot. So, And it's as simple as that. To start, this is a baby problem, right? We're still in infancy here as we go along, but it, executed those commands as you saw. All right. So there's another way to do this, although not through a program per se, but if you're working at the command line and just want to try these Python commands right then and there, you can bring up a Python command interpreter right there in the IDL by entering these 3 greater than signs. And now after that, this is all Python. So this is an IDL XL. These are actual Python commands you can run within the IDL interpreter. You can get the variables from some of these after this ends. The help will show you how to do that. We're not going to get into that right now. But if you were to run these, you'd get the same plot that we just saw. So we're not going to do that again. We're going to go on and show an example of the Python and IDL bridge with a similar example. So here, remember this is Python calling IDL now. So the key line to start focused on is this one I highlighted in yellow. So just like any other Python package or library, this is kind of the mechanism you use to get that in. So to bring in IDL, you use this IDL-py library. So we're going to import IDL in there. It's our variable. And once we start that, now I can execute. Now I can have access to all the IDL routines that are part of IDL. So this FinGen function, if you're not familiar with it, just creates a floating point integer array that starts at 0 and goes to 999 or 99. Sorry, because we're creating a 100 element array, and we're doing some calculations. So to the left of the equal sign, all that results initially into an IDL array variable, which then gets assigned to a NumPy array, all behind the scenes. We don't have to think about it. And then we take that NumPy array variable here, assign it back to an IDL, pass it to a sine and IDL sine and cosine functions. So there's a lot of IDL and Python interacting together behind the scenes that we don't have to think about. And then for our graphic here, we're going to use this map function, and we're going to plot the x and y values that we just calculated, and you'll get this graphic over on the right. So in the middle here, this is Python's IDLE environment. We're going to use that for this time only, to show you that it works, how that works. So we're going to exit out of here. Minimize this again. Go back to our command prompt. For the next few exercises, don't kill the command prompt. Just keep it running so you don't have to start it up again. Just type exit at the IDL prompt. And before I do that, let me go back to Visual Studio Code so you can see the function we're going to run. There's this Python IDL map.plot Python function. So these are the commands you just saw in the PowerPoint. So we're going to load this and we're going to run this. All right, so at the command prompt here, we're going to type IDLE, which is dangerously close to the IDL development environment command too. And then we're going to do file, we're going to do open, and we're going to select the Python IDL map.plot, IDL map.plot.py. And there's our commands. And just as easy, we're just going to hit run. Just executing those commands brings up IDL, as you can see there. Brings this plot, and it's exactly how we saw it in the PowerPoint. Okay. Hopefully that's all clear. These are, I recognize these are baby steps here. Just kind of showing you the lay of the land. So we're going to get into more exciting or meaningful examples in a second. Okay. All right, so back to our PowerPoint thing.
Hey, Greg, we had a quick question.
Yeah.
How can someone edit the IDL-Py.bat file?
Well, it's in your distribution when you get it. So just use an editor, text editor. I'm using Visual Studio Code. You can use Notepad++ and just edit it, save it. Yeah, it's as simple as that, really. Hopefully that didn't answer your question. Let me know. There's if I can be more specific about it. But it's as simple as take that file, change this to what yours is, where Anaconda's installed or Python's installed, and change this if it's different. Probably default. It's probably the thing you have to change. Yeah, hopefully that answered your question.
Yep, good to go.
All right, cool. All right, so now we're going to ramp up those are baby problems, just to kind of make sure everything's working right. I'm going to use some of the ENVI capabilities because I spent a lot of time in ENVI. I have a lot of ready-made functions available to me. But like I said, those of you that use IDL a lot, I'm sure you have a lot of your functions. So wherever you see ENVI stuff, imagine you have your functions and routines replacing those ENVI things to do whatever you're doing. So we mentioned before, it's a large, sophisticated IDL application. James showed you guys that before. We'll bring it up a couple times through the course of this. We won't delve into it. We'll just do some basic things. But besides just the user interface, there's that library of routines that are available to us developers for customization. That's what I spend a lot of my time helping our customers do, customize ENVI, add new extensions, add new applications, new processing capabilities. And so I have access to all those routines because one, they're accessible through my IDL API, and therefore I can leverage them with this Python integration as well. And we already talked about those separate ways. I won't belabor them again, but here's the ways we're going to talk about as we go along. So, all right, and some of the cool things that ENVI has that we support, 70 different types of sensor types, satellite data, airborne, LiDAR, multispectral, hyperspectral, SAR, you name it. We cover the gamut of not just the sensor types and sensor modalities, but the data formats that those data sets come in. We have a library of analytical routines. We call them ENVI tasks. If you stay tuned to the next session, the next seminar in a couple weeks, we'll be talking about the ENVI tasks too. So I'm not going to belabor them too much. But this integration allows us to use leverage their investments that they've done in ENVI and IDL, as well as Python, to get the most value out of both of those capabilities. So on the right, you see, it's familiar already. If you're in Python, this is how we bring in IDL, this first line. Then we bring in ENVI by ENVI's an IDL function, right? So IDL.ENVI, in parentheses, there's, you want to run this in headless mode. You don't want to bring up the ENVI display. So you want to set that headless keyword equal to 1. This will look very similar to when we're doing this IDL. And then once I do that, I have access to all of ENVI's routines. And so we can create an instance of this ENVI task, a spectral ENVI task function. We want to run the ENVI spectral indices task. This line right here opens up the input file. It gives the instance of the image object that we're going to pass to other things. You'll see that in the program there. And then from an IDL point of view, we start ENVI like this. We could put this as headless, but we're in this case, we already have ENVI running, so we just get the current instance. We open the file just like that, and we get the ENVI tasks, very similar to the line above. And then down here, we did some processing. We're going to get the data out of the output of the file, pass it to an IDL array that we're now going to pass to ultimately this Python char filter. So you'll see this in an example right now. Hold on a second. So this is just here to, you can point these out. We'll cover these later. So, okay, so let's see this in action. So here's an example. We're going to go, we're going to be in Python, and we're going to call some of the ENVI routines, and produce a result and plot this in Python. So here's the workflow in the middle of the screen. So we're going to start ENVI in Python, much like you just saw us do in the code on the previous slide. We have ENVI open the file, ENVI read the data, and then ENVI's going to pass. Then we're going to pass that array, image array, to this char transform filter, which is a Python routine. And because I want to display it, it's going to look dark. So I'm going to have Python apply a 2% linear stretch, and then we're going to plot the results in use Python to plot the results. So if you run this, yours should look just like this. So let's do this in action. So we're going to be running this plot edge filter.py. We're going to first bring it up in Visual Studio Code here. So plot edge filter.py. Okay, so this is what this looks. I'll point out some of the key things about this routine. So first of all, this is how those Python experts, this is how obviously we import different libraries. Here's the importing IDL in here as well. We're importing PyPlot and the scikit image library here, and we're going to be using their char filters. So here we're starting ENVI in IDL. Starting ENVI here. We already got IDL initialized. So we're going to start in ENVI. The headless equals 1. These two lines are allowing me to enter my input file on the command line. And then we're opening up the image file. We're reading the first band out of the file, and then we're saving that as an array variable that we've now passed to these three different char filters. And then these package lines right here apply the 2% stretch to each one of the outputs as well as the input. And then these few lines in here display or create the display axes and all that stuff to show it. All right, now that you've digested that really quickly, let's see it in action. So we're going to go back to our command prompt here. And we're going to type Python plot don't hit enter yet, hit space. We got to get our data. So rather than hard code the data in here, I added the ability to add a command line prompt. So in your training directory, there's this course data folder. It's parsed down to that, and there's a neonurban.data file. It's a 4-band image. Copy the path over here in Windows. Just get a copy of it. And then you come back to your command prompt, hit the right mouse button, paste it there, and now you can hit enter. And now you see it starting IDL. There's it loading. There. Now, my graph looks kind of funny because I'm using this massive big screen to kind of show this on here. So if I run this on a laptop or a regular computer, it has better fonts on here. It doesn't screw up, but it does look exactly like, it should look exactly like it shows up in the PowerPoint slide here. So just a quick recap here. So we're using Python to call ENVI. We're letting ENVI do some stuff for us. Then we pass that data array to our Python filter, Python routine. We let it do some stretching to the data, and we're plotting the results. So that's a fairly decent example. So now what I like to do, let's go the other way. So I'll start an IDL and ENVI, and I want to call that same char edge filter, Python filter, and transform from within IDL and ENVI, and I'm going to display the results in ENVI. So, so here's the workflow over to the right. We're going to, we start IDL, of course. We start ENVI and IDL, then we're going to open the image file using ENVI. We're going to add some other functions and other ENVI tasks into this workflow. We're going to compute an atmospheric correction, which basically converts this data to ground reflectance. And then we're going to use another ENVI task to compute the normalized difference vegetation index. We have We have 170 of those, so I can compute. There's about 60 or 70 or 80, I think, different vegetation indices, spectral indices that I can use. I use NDVI for simplicity. And then we're going to compute the SHAR filter, and then we display the results in ENVI. The graph is going to look similar to this, except for this text right here. Okay, so hopefully everybody has that. So the routine we're going to run is this display edge filter from python.pro file that's in your distribution. So I'll go real quick to here. This is what it looks like in Visual Studio Code. We are going to go though, instead of here, so we need to go there anyway, is we're going to go over to IDL. Oh, now I got to kill my plot here. Okay. So from your command prompt, you want to type the IDL-DE, not IDL-E, IDL-DE for the IDL development environment. So we start it up. Okay, sorry, leftovers from when I was practicing. So let's go File, Open, and we go back to our training directory, IDL-Python bridge directory code. Select that display edge filter from python.pro. Open it. Okay, leave that there for a second. Come down to the IDL console down here at the bottom. By the way, this is IDL's development environment. It's Eclipse based. It's where you want to do an ENVI and IDL development. This is what I use as debuggers and all kinds of stuff to help us develop the code. But at the bottom, we want to start up ENVI. So we're going to type E equals, like you saw in the code, equals ENVI. Open close parentheses, because we don't have a current version, so we're going to start one from scratch. And it'll pop up in a second. And then the next thing we're going to do, we're going to get this to my screen, bring IDL back up. There we go. So just make sure you click into the code somewhere. Let's hit the compile button and hit the run button. And then we're going to select our file. So we go to training, course data, select our same file. Sorry for the repetition on the data files. It's easier this way. Hit open. Then we're going to switch back to ENVI. And you'll see it's doing its calculations. So I don't know why this keeps coming up right during my session. Okay, so this is ENVI. So what it's doing, it divided our display, our ENVI display, in a 2x2 layout. We'll look at the code in a second. 2x2 layout, it loaded the original RGB image in the top left, the NDVI calculation in the bottom left. In the top right is the SHAR filter. So we'll do a view. We click on views. We're going to link these together. We'll link them all. It's really only doing it for 3 to have stuff that has things in it. We're going to click on this one. Maximize, view to extent, so you can see the whole thing there, right? One of the things we'll do, one of the things I noticed is, I looked at how this thing was outlined, and I noticed that, hey, this is outlining all of the vegetation. NDVI is pretty bright. This is looking for transition between bright and dark. And so if I take the SHAR image data and just drop it on top of the RGB image, and then I take our slide, I'm going to zoom in a little bit. So I link them together. And then when we hit our transparency, you'll see, pretty cool, it just highlights look at the white around all the trees, not around the buildings or the roads, it's around the vegetation, like this grass area right here. I noticed that, hey, this is pretty cool. If I want to create a mask for all the vegetation, this would go away. And so it highlights the vegetation, or I can swap it around, and I can get the non-vegetation. So as well. So create a mask for, say, for impervious surfaces or something like that. So it's a pretty good, interesting output. Hopefully that message will come up here. Okay, so that's that example. Hopefully that was easy to follow. Go back to our.
Hey, Greg, we got one more question.
Got a question. Okay.
Jennifer has installed Python version 3.7. Does she need to install 3.10 to work with this?
Yes, it will not. That happened to me. I grabbed the latest version, and it had 3.7. So if you have 3.7, it's not going to work yet. You're gonna have to get to 3.6. So I would recommend you can try doing a conda install of 3.6.10. That may or may not work. You may, if that doesn't work, you may need to uninstall that and uninstall the 3.6.10 version that, or 3.6.5, and then update that 3.6.10. I spent a lot of time trying to make sure I got all these configurations right, because there's a lot of options out there, and I found that Anaconda was pretty smart about trying to figure out all the different variations, but it was still a bit of a challenge to make sure I got it right. So yeah, if you wait, the next version of ENVI and IDL, I believe, will support, I've been told, will support 3.7 and 3.8, I think. Okay. Any other questions with that regard? Yes, that's a summer release. Yeah, so Jennifer's asking whether that's a summer release. Yes, this is coming out in somewhere in the July timeframe. Okay. All right. So now we've seen the IDL bridge, IDL Python bidirectional bridge working with ENVI in Python world and IDL world, and bringing the goodness of both of those into each other. So I want to shift gears a little bit and talk about this Mdpi engine that I mentioned a couple times, didn't have time to explain yet. So what this is, it's another part of our integration that allows, it's a Python package called Mdpi Engine that allows us to run our ENVI analytics, mainly our ENVI tasks that are provided in our desktop tool through a consistent methodology and through Python. So it's a different way of accessing these tasks than the IDL bridge. It has its pros and cons, advantages, disadvantages, depending on your point of view, but it allows you to query for the tasks that are available, retrieve the task information, execute tasks as well. Like I said, we're going to be talking about ENVI tasks quite a bit in the next seminar. It's not limited just though to the ones we provide. As I mentioned, you can build your own tasks. We'll talk. That's what the focus of next seminar's topic is all about. So, but one of the advantages is that when you run using Python to do the Mdpi engine to run an ENVI task, it accesses the license just for as long as that task is running, then it's done and it frees it up. So, whereas if you're using the bridge like we were using before, you're accessing your ENVI and IDL license until that Python instance ends. The other disadvantage, especially from my point of view, is that, well, if I do this, use the Mdpi engine, I don't have direct access to some of ENVI and IDL's routines like I did before. So there's no access to the IDL FinGen. I can't use ENVI directly to open file up. I have to use the constructs that are defined here. So it depends on what you're trying to do. Really, if you're trying to do production level stuff, maybe this is the way to do this. This just hands-off kind of processing. Maybe this works for you. We'll show some ways how you can leverage this. So in this example, we're gonna chain some ENVI tasks together using that Mdpi engine or the task construct that you saw before. So we're gonna import the engine here, package, get an instance of it. We're gonna call the NDVI task, we're going to call a linear stretch task, and we're going to export our export to TIFF task. The reason we're doing that is because all these tasks create, their outputs are ENVI files. Python doesn't, the standard Python doesn't know how to read an ENVI file. And so, but we can export it to a TIFF file, and this pillow package knows how to open up a TIFF and display it. So this shows us how to, this will show you how to combine multiple tasks together in this other construct. So we're going to focus on this ENVI Engine full example.py. So first thing we're going to do and go to our Visual Studio Code here. I'm going to close that, and there's a separate directory for that. So you go to your IDL-Python Mdpi Engine directory here, and then we're going to look at this ENVI Engine full example. There's some extra things we'll get to later on about that, but we're going to focus on this one for a couple reasons. One, here's, you saw on the slide before, here's how you import the engine, get an instance of it. We're going to use Pillow, so we added that to our instance of Anaconda, so this is how you start that one up. We're getting an instance of the ENVI engine here, and then we're going to get an instance in this line right here of the spectral index task. And now we have to set the input and output parameters. So use these dictionary type variables in this construct to pass whatever your input file is to raster. Now, the reason we use this is used by needed mainly to support our enterprise type app or enterprise deployments. So you can't pass ENVI or IDL binary variables around. So you have to use these JSON type structures and dictionary type things, even at this level, to kind of pass those things through RESTful type interfaces. So it's leveraging some of that technology for here. So here we're just setting the input rasters, how you would do it here. We want NDVI again. We set the parameters in this dictionary variable, you'll see input raster and the index. And here's how we execute that spectral index task. Gives us a result, a JSON result back. And these three lines are about extracting the outputs from that spectral index task so we can pass the output file to the linear percent stretch raster. I know I'm going kind of, seems like I'm going fast here. We're setting some of the parameters, like we're going to do a 2% stretch, and then we set up the parameters again. We pass it to the task to execute. We get its output through these three lines here to pass to the export raster to TIFF task, and we execute that one, and then we get the outputs again in these lines so that we can pass that to the Pillow image open and the Pillow display function. So it seems a lot of text there. It's not really that complicated actually once you get the hang of it. So what we're going to do next is we are going to run this in live. We'll run this and show you how this works. So ultimately we're going to get something that looks like that. Okay, so we go back to our command prompt. So you have two choices. You can kill this and move it over to the other directory. I'm just going to change directory a couple times. And then I'm going to IDL-Python the engine, Pi engine, change directory to code directory. I did this so I don't have to type the IDL.py again. So and now we do Python here, ENVI engine. Oops, okay. Let's see. Oh, okay. I gotta go back to my get a copy of my path to my data set. Paste that back on there. Hit enter. So I added some print statements to this, though. it remind me that things are happening. So it's printing input file name. It's going to run, remember, it's going to run the spectral index task. So it created NDVI. There's its output it creates. Then it's going to stretch the data. So you're going to get the 2% stretch output file in a second. There you go. And then it's going to convert this thing to a TIFF file. And then once it does that, then Pillow is going to display that file. And there it is. So it looks exactly like the one we have in the PowerPoint slide. Okay, so hopefully that was fun. You guys are following all that. Let's see. Okay, one more example about this. Yes, sir.
We got one more question. For the spectral indices ENVI task, do the header files for the output report which specific bands were using in the index calc? For example, the hyperspectral data.
Okay, I'm sorry. Repeat that.
For the spectral indices ENVI task, do the header files for the output report which specific bands were using the index?
Oh, okay. So that's a good question. So the cool thing about spectral index, the way the ENVI tasks are, especially this one is constructed, is it will read your wavelengths. You need to have wavelengths in your file first to use this one. It will, depending on the spectral index that you're trying to run, it looks for specific wavelengths in your header file. If that file does not have those wavelengths, it will not allow you to run that index. So the spectral index to run NDVI requires a red and a near infrared band. If your file only has 3 bands in it, you're not going to be able to run that index. Or if you don't have your spectral ranges and cover those spectral ranges, it will not allow you to run it. And that's same. So every spectral index has those kind of definitions and it has wavelengths that it runs on. So you will only be able to run the index that's appropriate for that data. And there's another task, spectral indices, that will give you the whole list of indices that you can run based on the wavelengths you have present in your data. So I encourage you to kind of look at the help on those particular tasks, and you'll see for each task, for each index, there's a definition of what wavelengths are needed to run those in the help. Is that your question?
Yep, so, and this is James. So like if you had those 50 red bands and 50 near, if you go into the help as Greg stated, each indice tells you what the specific bandwidths are. And so when you actually run that spectral indice and you look at the metadata, if you actually go to the spectral portion in the header, what you will actually see is what indice fit for that specific data set that you ran. So you don't see the individual bands that it ran against, but if you have a question as to what specific bands, then every single indice lists out what that band math equation is and what those specific band ranges are. So as long as your bands fit within that range that was set for that indice, as Greg stated, you'll be able to run it.
Yeah. Exactly. Okay, it's in the help. All right, but it's a good question though. Where is that? Oh yes. Okay, that was a good question. So now we're gonna do another example that leverages the Mdpi Engine construct here. James, one of the coolest features we've added in ENVI recently is this ENVI modeler. Those of you that use ArcGIS with the model builder are familiar with how this is very similar to that. It's in our environment now. It allows us to build. The cool thing, you can build your workflows. If you're not a programmer and you have enough knowledge of how to chain different algorithms together, you can do this without programming. And so you see at the bottom of my screen, here's a model that I built in the ENVI modeler that does the task that we just talked about, that we just had to code that we typed in there, and with this builds the workflow using ENVI tasks. We'll get into that in a second. And then the cool thing about it is you can save that code as a Python. As one of the options to save it as Python. And so it generates something that you see on the right. It combines this whole workflow into what we call an ENVI meta task, which is a collection of tasks in a JSON structure, so we can pass it to the execute task execute function. And so now it generates Python code. Now you're still going to have to you're probably going to want to make some edits to this thing. We'll talk about that in a second afterwards, but because we still want to display it, so we need to import pillow in there, and we need to extract the output out of that JSON structure that comes out at the end. So we need to make some edits, but most of the code is written for you, and we'll run this in a second. But what I'd like to do is go see this in the ENVI modeler. So we're going to be using this NDVI to TIFF model real quick. So we're going to back out of this, and I'm gonna at least restart ENVI. IDL should already be checked here. I'm going to restart ENVI here. So the cool thing to leverage this, to use a modeler, and we'll talk about this in 2 weeks, you need to have ENVI tasks. Like I said, we give you 170 plus tasks yourselves. You can create your own and add them. And once you create these tasks, you can they become available with the ENVI modeler. They become available with our GSF instance. They become available to add to ArcGIS. And so there's a lot of power in these ENVI tasks. So here's the ENVI modeler. At this bottom is the list of all the available tasks, whether they're ones we provided or custom ones. We're going to go up here to File Open, and we're going to open this SE Vegdalin model. This Vegdalin model is just a different variation of that. It does the same thing. For simplicity, we're going to use this one. But you're welcome to look at the other one at your leisure. Just a different way of doing this. So here's the model. Just a quick rundown. It's just as easy as there's these nodes here that allow you to pass input parameters, output parameters. We're going to take this view one. We're going to stick it in here. This is how easy it is. We want to display the input file. We're going to click on the input raster. Connect those two together. We want to see the output of this thing. So we're going to connect that to there. As easy as that. And I do this when I create these just to make sure they run. So I'm going to click run. It's going to ask me for an input file. So I'm going to go and select, you guessed it, the same one we've been using. Sorry. You can use others. Just make sure they're forward band files, linear things. You can use those. Hit OK. Okay. And then it runs. And then because I hit the view, it's going to display the results right here in ENVI. Oh, I picked the wrong one. Sorry. Mixing example. Okay. This is for the next one. Sorry about that. So go to the data manager and let's clear all these out. Hit the little X, close all the files. Sorry about that. Never happened in my rehearsal. That's funny. Okay, let's just, you can leave that one there. Just to go file open again. We're gonna go back out to training. I didn't go to the right directory. Go to the Mdpi Engine. Click on this NDVI to TIFF model. Sorry about that. Getting ahead of myself. So, okay, so we're going to grab the view again. Stick that in there. We're going to drag the input raster window over to here. There we go. Grab the output raster. output TIFF in there. Click on these drop downs right here because we need to select our data set. Not that one. You probably don't have that one. I don't know why that one stays. Go back to your training directory, course. Back. Now we got the right one. Hit OK. Hit run. There we go. And then it shows up in this one. Okay, so that's that. Okay, so let's get rid of the view because it's not going to do us any good when we go into Python anyway. So we just delete that. Just make sure it all runs properly. We want to come over here to code. And it's where it gets fun. So go to the code button for you guys that can build these things and want to learn about programming, and especially in IDL and maybe even Python. You go to code button here. If I click on the generate IDL program, it generates you an IDL routine. And you'll see this in the next example of this workflow that we just showed, this model that we just showed. All the commands all laid out for you. And if I left the view in there, it would add the code to display the view in it. So that's pretty cool. You can create an extension as well. And now it would show up under your custom that you can add it. It'll show up under your toolbox on the custom extensions. But we're going to go to Python here. Oh, doing pretty good. Okay, so we're going to go to Python. So it generates a Python routine, as you can see. Click on the wrench. We want to make sure it's going into the output directory we want it to go into. So C:\training. Course data, you stick it there. There's a ENVI out folder. Stick that there. Hit OK. And then we're going to hit save. Save this file. We make sure you put it in the ENVI Engine, IDL-Python, Mdpi Engine directory, code directory. You can name whatever you want. I'm just going to leave it as myprogram.py. That's fine. It's easy as that. Okay, we're going to go back to our Visual Studio Code or your editor. That one. And now that myprogram.py is already here, so let's open that. And then there's another one called ENVI Engine Example Metatask. So open that. I suggest open to the side. If you do side by side in your editor, that'd be easier. Compared to two. Now this is the one we're ultimately going to run. That I worked out all the extra things we need to add. So we need to add pillow. So you can come over here and just type on your program from PIL import image. Make sure you type in the same. Okay. And put a space there. Then all you need to do there's no place where you can easily add that task file from the command line. That's some work that I didn't get a chance to go work out because you have to edit. Your input file is embedded into this JSON structure, so you have to go and mess with that to append that thing there. So I didn't have a chance to work that out yet. So maybe in a future update we'll describe that, or maybe put it on our webpage or something to show how you do that. But we're gonna go to the bottom because this is where it executes that whole thing. This result is just a JSON output, so we want to come down here, and I worked out how to parse that. So if you're following along, just grab these lines, copy them, paste them right here into the other routine. Then come over here and save your my program routine. So all these are going to do is just parse out your output file, your output TIFF file from the JSON structure that gets returned from this this TIFF task. So kind of the same thing we did before, and then we pass the pillow display open in display. So we're going to go to Python. We're going to go back to our command prompt. Okay, so then all we need to do in this case is type my program .py, hit enter. Now, unfortunately, there's not going to be any printouts until the end, so it takes a couple seconds. Let's run the exact task that we ran before, both in the modeler and both in the code in the other example. And then you get the same result. Note that here you see we printed out that it's an ordered dictionary variable output that comes back that we parse through to get the output file. Okay. So hopefully that was helpful. So we've finished. So I think we're going to take a quick break for questions in case people have some questions before we move on to the ArcGIS section. Does anybody have any questions that we need to ask now, or do we want to go, or should I just keep on going on?
I don't have any questions currently, Greg, so why don't we keep on going, and if we get any, I'll update you.
Okay, no worries. All right, so now I want to shift focuses now a little bit to some of the work we've been doing with that we can do with this technology with ArcGIS. They're one of our partners. We've integrated ENVI and ArcGIS since 2008 at various levels, and this Python IDL and Python integration has evolved over the years as well, and it's a lot easier to use and work with these days. So this example, though, which I've been wanting to do for some time, is that James showed you how to, and we'll talk about this a little bit too, show you how to take ENVI tasks and deploy them into these ENVI toolboxes. And if you get if you have ENVI and you get ArcGIS and you install these things, you get ENVI tools deployed into Arc Toolbox, as you can see over here. So you can get these, these things. You pay for ENVI, you pay for ArcGIS, so this comes for free. If you build your own custom ones or want to add other tasks to your Arc Toolbox, that's great too. From the Arc Toolbox user, they have access to those functions in an environment they're probably more comfortable with, and that's fine. These will run. ENVI will run behind the scenes. You still need a license for ENVI though, but they'll run behind the scenes, and you can combine these tools with other ArcGIS processing functions tools as well. For instance, in like model builder. So what I wanted to show though is all the stuff going into Arc, ENVI stuff going to Arc. I want to use some of the Arc stuff in ENVI. How do I do that? So this is what that I killed that. So this is what the so we're going to try to pull ArcGIS stuff into ENVI. So here's an example for this, how to do that. So first thing we're going to do is we're going to from a IDL standpoint, you saw earlier, we need to bring in the ArcPython library. So it's called ArcPy, just like we did a regular Python library. We use that python.import, give it its name and quotes, and now you have an instance of it, and now I have access to the Python functions. So we have this, to show this example off, we're going to do this ENVI veg.delin geoprocessing to shape.pro. We're going to open that up in the workbench. And so before we do that, we'll talk about what you're going to see. So this is an IDL program. So we're going to open up ENVI. We're going to compute Mdpi using the spectral index task again. There's a task called image threshold. So we're going to threshold this thing into 4 different classes. No vegetation, very low, near 0 or less NDVI values. Sparse vegetation, which we colored yellow, moderate vegetation, colored that lighter green, and dense vegetation would be the darker green. So these are just different, the vegetation ones are just different ranges of NDVI values, just kind of get the idea. And then what we're going to have ArcGIS do is we're going to have it take that ENVI classification image that's going to produce and convert that classification, those 4 classes to separate vector layers. So ENVI has one to do that, but this is one that I wanted to show just so we can demo. It makes sense to do that. And then we display the results in ENVI. So at the top you see the classification image. On the bottom you'll see the true color image with the vector outlines. One thing to note is that shapefiles don't have color attributes that you can that automatically get assigned. So there's some work you'd have to do to go and change the colors of that. I'm not going to go through that today, but that certainly can be done. And that's whether you display it in ENVI or in ArcGIS. So the one note is that the integration we've done over the years, ArcGIS already knows how to handle or read ENVI files, especially this classification image file. And so there's no extra special thing I need to do. It's just it's an ENVI file going into Arc right here. So, all right, let's see this in action. So we got to do a couple things first. First, we got to back out of this. Thank you very much. Minimize this. We need to close ENVI and IDL. So we exit out of this. And then the next thing, if you're running Arc Pro, you need to start it unless you have your license as a offline activated your license. So I didn't, so I have Arc Pro just running because it connects to my ArcGIS Online account. I don't believe you have to do that for ArcMap. You definitely have to do it for Arc Pro. Then the next thing we want to do is, we get rid of our command prompt. So we close our command prompt because we can't use this one with Arc. So now we're going to go back to our Windows Explorer here. We're going to go back to our training folder. We're going to go to the IDL-to-Python ArcGIS folder, code, and start the command prompt up again. And there are other ways to do this. I agree. I try to make this simple for people to follow. And there's a directory, there's a file in here called load ArcGIS Python I mentioned earlier in the presentation. So this is the batch file that sets up our ArcGIS environment with IDL and Python. So you want to run that. This takes a little longer because it takes more stuff that ArcGIS needs to load. Okay, so once it does its thing, then we're ready to go. We'll start up IDL, the IDL development environment, and we'll start up ENVI just like we did before. Oh, there we go. IDL DE. And then at the IDL command prompt, you want to type console down here. You want to type E equals ENVI here. Also do. Well, you still have yours, so we'll close that too. We're going to do file open. And training, Python ArcGIS code. The vegetal NGO process, you want to open that one. You can open the other one as practice. It's another one very similar to this. So what I did here is I actually started off with a model. And that I created a model off the one you'd seen before. So, and then I saved that code to save that IDL code. So that's what you get And then I made some modifications to it because it didn't have the ArcGIS stuff in it. So I added this, much like I did the Python code for the metatask, and I added these lines to it, mainly to check to make sure file names didn't exist anymore, didn't delete them. But then I ultimately imported ArcPy. I added the input file to this workspace that you have to do. And then I called this raster to polygon conversion. It's the ArcGIS geoprocessing tool. And I'm passing in my classification image that I ran, and I'm going to generate polygons. Then I test to make sure that these polygons were created properly, and then I'm going to display the results in the ENVI display. So what we're going to do, we can let's go compile that, and we can run it just like we did before. Select our raster. Another favorite one we're going to pick. There we go. So you'll see it. The progress bar is doing stuff. And also you're going to get that result here. Displays ENVI, displays class image, and displays the ROI. ENVI's default color for shapefile is going to make it red. You can change the others, but really behind the scenes, you want to go and change these different vector layers to a color that matches this. We're not going to take time to do that here, but this is the result you would get. You should get. Okay, so that shows us how we can bring in ArcGIS, the geoprocessing services or tools into our ENVI and IDL routines. So this next section, this final section we're going to go. This is the final section we're going to go through. I'm doing it on time. I got to hurry. Okay, almost done. So this last section we're going to do is taking a tool, taking a model, publishing it, and creating you can create these toolboxes programmatically instead of manually doing like you may have seen James do them before. So we can create these programmatically. I'll show you how to create the toolbox here. Well, first we're going to create okay. So first we're going to go back to back to ENVI. Sorry. Let's close our files here. We go back to the modeler. We're going to open up in the ArcGIS directory. There's a model in there. This sveg, the Lin one that I told you about before. Okay, so we got that. We already ran it before, we know it works. So here we're going to go to code. We're going to generate a meta task. Okay, we're going to publish this task because this is a task that I like. It works. There's no veg to lin task in your standard distribution. So now we're creating our own custom task, and so we created a model. Now we can publish this task. So we're going to call it. So you want to type this exactly because we're going to use some code that I already wrote. So vegetation delineation. So you type it correctly. Okay. Leave all the rest the same. It's going to put this in my custom code folder and your custom code folder, wherever that is. That's where your task can go. Say this computes. I'm going to save time here. Okay. You could, at this step, also publish the ArcMap and ArcPro. We're not going to do that. We just hit OK. Got to delete that out of here. Oh. Darn, got deleted out there. I'm gonna tack on a 1 there. Sorry about that. Okay, so let's save now. And so I'll have to make a minor edit to my code here. So here, delete that, go to ArcPro, ArcGIS here. Okay, go to our ArcGIS, IDL-Python ArcGIS directory. We want to click on this ENVI Vegetal in ArcTool.py. Okay, I need to make, so we import our engine, we import our Mdpi ArcGP toolbox library, and then we want to run this task. I called it yours would be vegetal delineation. Mine's gonna be 1 because I already had it out there. And in here, so that made it, I have to change this here too. Sorry about that. 1. And now I can run this, and I'm creating a toolbox called Yoda ENVI Arc Tools. So I'm going to go to Python now, back to my command prompt here. That's an arc, so you need this one. Don't go to the other one. Save that. So now we want to run Python NDVI tool. We need a command. It takes command line, so I guess we'll get our data set again. Path to our data set. Also this will all come cool in a second. Go hit enter. So now it's going to create in my training directory. When it's finished, it's going to create a toolbox. That's still running. A conversion to Polygon 6, and that's done. Here. We done? No, it's done. Sorry. Let's see it. Well, that's supposed to be there. I don't know what happened to it. Where'd it go? Okay, of course, always a challenge. So anyway, it's supposed to be there. There it is. Okay. Anyway, you get a toolbox, and then you can import that tool into. I'll skip that. I don't know why it's not showing up today, right now. But anyway. So what you'll get is you'll get a toolbox. You'll be able to open up ArcPro. You'll be able to come and add this toolbox to your tools, and which you get this vegetation delineation, which you can then run and you'll get the same result as we got for an ENVI. Now here I didn't add the Python geoprocessing tool here. What I would do is then bring this, since this is now in ARC, I would go over to bring this in into Model Builder, connect my digital into that geoprocessing service, and then produce my result. Okay, I don't know what happened, but that happens sometimes. Okay, so the last thing I want to do is we just mention real quickly, I mentioned earlier, you can run, we do support Jupyter notebooks, so you can bring IDL in there into this environment if you're comfortable with doing that. And so you can access and generate these things in a web browser, run all these commands, generate this plot that these commands generate. So yeah. So that basically concludes my presentation and demos. Hopefully that went well, except for the last part. Not sure what happened there. Here's all the contact info for my other colleagues that you've seen before if you participated in there. I thank you for your attention. If you have troubles with the materials, let us know. If you have troubles with getting the Python integration working for you, let us contact tech support, give us a call, send us an email, and we'll be glad to help you out. But thanks a lot, everybody.
Yeah, just like to echo what Greg has said on behalf of the Harris Geospatial folks, the Defense and Intel team specifically. And obviously, you see these names. If you have questions or any specific thing you want to ask after today's webinar, feel free to reach out to any of us on this webpage. We'll be happy to get to your questions. With that, we'll see you all in a couple of weeks. Thank you very much.
Hey, Spencer, we actually have one quick question. Someone wants to know if we have any Canadian POCs.
To whoever asked, to whoever asked
Joey.
that, if you could email Joey Griebel, his last name, his contact information is at the bottom of the screen here. If you can email Joey Griebel, he'll be able to put you in touch with the proper person.